Hi, my name is Marcelino Gutierrez. Welcome to the CIER-MMI 2022. Thank you for the invitation, and I'm gonna be telling you about our work that a group of co-workers did thanks to the University of Guanajuato and University of Querétaro, and I hope you enjoy it. Nowadays, optical fiber filaments have been used in many applications. For example, in data transmission, internet connection, some kind of sensors. And basically, the thing is that when you have a long distances of filament or a big amount of this filament, the idea is to create a machine that can wind it with a precise exact amount of filament. It means that if you wish to have, let's say, 1 kilometer, 10 kilometers, 100 kilometers of filament, you're sure that you're gonna have the amount of, or the quantity that you are requiring wounded for. Well, optical fiber filaments have been used in many applications. In this case, for example, for data transmission, internet connection, some sensors. And the idea of this work was, since this group of colleagues were working with filaments for some applications, we saw the necessity to have this device in order to collect smaller spools of optical fiber filaments in order to transport it and use it and take it from one application to another application. That was the idea, how to transport it without wasting filaments when we translate it from a main big spool to a smaller one. So as I said, well, optical fiber filaments have some other applications. In this case, for example, for filament detectors for 3D printers, or strain and temperature sensors, or even for human biological sensors also. For example, to send some fluids in human body. Well, the idea of building this optical fiber winding machine came when we were thinking about buying one of these winding machine, but the budget that we had was not enough to buy it. And since we work with this in some projects, we need one of these devices to be able to transport or to get just some amount of optical fiber filament, not the whole spool. So when we saw this situation, we decided to build our own winding machine. Even though there are several machines in the market, well, we had the idea, we took the idea from some of them in order to build our own device. Well, our device, what it does is that it has a spool holder where the spool is placed in its position, and then we're gonna have a filament aligner card, which is gonna be in charge of moving from one side to another side in order to be placing the filament. And as soon as the spool starts turning, filament is gonna be wounded on the spool, and then the car is going to be moving from one side to another side in order to have several layers of the optical fiber filament. And it has to be precise because it has to go up from the beginning to the end of the spool, and then comes back and go back and forward and so on until the optical fiber is wounded. I mean, the amount of optical fiber that is required. And on picture that it's on your left, you can see the parts that are involved with the construction of this equipment. For example, we have step motors, which are used for the lightning car, and then you can see a DC motor connected to an encoder, an incremental encoder, and this one is used to wind the optical fiber. And well, the DC motor, it's connected to a DC motor drive, which is gonna control the motor speed. And well, the DC motor drive is connected to the main board, which is an MEJA board where the whole system is implemented. And then it has a display, and then it has a keyboard, and you use a keyword to program and set the parameters. For example, the amount of optical fiber filament, the inner and outer diameter of the spool, and the diameter of the filament, the optical fiber filament, and what else? Well, the system has to calculate the amount of turns that they're going to be on the spool, but I'm going to talk about this part later. And then it has a time of flight sensor, which is used to set the aligning car at home, well, just to know, so the machine can know exactly where the car is, and it's going to start from this part to start winding the optical fiber. Okay, on this picture you can see physically how the machine is built, how the machine is armed. For example, you can see the DC motor connected to the encoder, and then the encoder is connected to the main board. The main board is also connected to the display and the keyboard, which are gonna work as a system interface, and the optical fiber filament base, where you're gonna place the big spool with optical fiber filament, and that's where you're gonna get the filament from in order to wind it on the smaller spool. So we have a spool holder, and this is the part where we're gonna place the hole, the spool in order to wind the optical fiber filament. And all the frame is made of aluminum, and as I said, this work is thanks to the collaboration of some professors, and some of us were working with the electronic parts, some of us were working with the mechanical parts, and so on. You know, it was a great collaboration. Well, for example, when a design is needed, in this case, for example, the quantity, the amount of meters that are going to be wounded on the spool, basically you have to set some parameters. In this case, for example, the inner spool diameter, the outer spool diameter, and obviously the amount of optical fiber filament. And then once that you set all these parameters on the human interface, on using the keyboard, well, the system takes a moment to calculate the number of turns and the number of layers that are going to be placed on the spool, and it can tell or can predict if the design is going to fit, is going to fit on the spool, or is not gonna do it. and the system suggests if you reset the parameters or you decide to introduce a smaller project or a bigger project. I mean, or it suggests if you have to change the spool for a bigger one. So, and we tried the system using filaments of 100-meter long. Yep. And we could notice that the amount of waste that we had uh, winding the optical fiber filament was really small. Like in this case, for example, the error was in this case like 0.05%, and so well the waste that we have winding with the system is really small, which is acceptable for us. So this project has a block diagram to explain the process, to explain the steps that we have to follow in order to have one design on the winding machine. And we decided to include it and show it to you so you can see it. For example, while you start, the sensors start functioning and checking the position, the car position, the spool, and everything is in its place. And then, well, you set the parameters, and then the system starts calculating if the project is gonna fit on the spool, and if it does, well, it's gonna continue winding. But if it doesn't, it's gonna go back and ask you or tell you that you need to replace the spool, or you need to consider having less optical filament, etc. Well, in conclusion, with this project, it has a really low winding error, and the user can have well, we had a fast development and suitable machine platform to have these projects, these winding optical fiber projects, without a big budget. And due to the modularity of the system, there are several future projects and opportunity areas for us. For example, in the next projects, we're gonna start thinking about using intelligent control algorithms, and then using this winding machine not only for optical fiber, but now for the copper wire winding, for transformer designing, using different gauzes and vision control. Well, I hope you enjoy it and find this project interesting, and we are willing to answer if you have questions. We'll be pleased to answer to you. Thank you. Finally, authors want to thank to the University of Guanajuato, and PRODEP, and the University of Querétaro, all of them for the support and supplies that they gave us for this project. Thank you very much.